Hello? Hi. Yeah, it works.
You guys ready?
Yeah, almost there.
Almost there. I'll buy you 3 minutes.
Yeah, thank you.
So welcome everybody. Welcome to any guests we have in the building, any clients that are here in the room. I will be the timekeeper instead of Dave. So projects that are presenting today, look for this 5 minutes, and be on your mark, then 1 minute. And because we have 8 projects, the stop is really important. We're going to try to keep you guys on time. 15 minutes for your presentation, up to 5 minutes for the Q&A, and then we're going to move on. We don't like these seats, so we faculty hate sitting in these things for hours and hours. So after 4 presentations, we're all going to get up and move around and take a bit of a break. So if you're presenting after team 4, you get a little time window because we actually get up and stretch and then sit back down. So that's coming, just so you're ready for that. So go ahead, settle in your seats, and we're about to get started.
I think we have one microphone that's
Esther 有 Hi, we're Team Lenticula's Lab. We're happy to kick off the presentation for today. And we're creating a game called Orbit, which is a strategic 3D game on looking glass display. And let me introduce my team. I'm Esther, I'm the producer of the team. And Cassie is our UX designer, and we are doing co-producing. And Arthur is our programmer, Jimmy is our tech art, and Lydia is our game designer, and Richie is our artist. Cool. Okay, so we have Derek come as our instructor. Okay, so speaking of the project overview, Orbit is a strategic space adventure game on looking glass display, which is a screen that enables 3D viewing without goggles. So in our games, player can scan, strategize, and shatter asteroids through spatial observation to uncover rare cosmic resources across the galaxy. And speaking of the goal, since the developers nowadays are still developing the killer apps and finding more use cases that can fully leverage the looking glass displays feature, therefore, as a team for this semester, we'll want to find out the possible solution to integrate depths with interactive experiences. And let me talk a little bit more about where we are right now. So during week 1 to week 3, which is our spring one, we spend our time identifying the strengths and weaknesses of the looking glass displays and getting familiar with the devices. And the next spring, which is spring 2, from week 4 to 6, we spend our time developing Orbit game to integrate the depths of the screen with the experience. So I'll hand it over to Jimmy to talk about our demo.
Thank you, and I'll walk through the demo video of our game, Orbit. So initially, the player will start as a spaceship whose mission is to collect enough spatial resources, and he can scan through all these asteroids and find a direction to shoot out a laser beam. And with the powerful laser beam, he can shatter all the asteroids in the way into smaller pieces. And then he can fly along the firing paths to collect all these resources. And that's the moment when the seemingly to the top-down camera perspective changes into the tunnel-like 3D perspective, so as to emphasize the depth of our gameplay. And now I'll let Arthur to talk about the tech part.
Tech part? I mean, tech in general, tech exploration. So the main job of our tech team is to explore enough features on Looking Glass so that our design team can use them in the creative process. First of all, let's start with the 3D monitor itself. Looking Glass is a display that uses multiple viewing angles, which means when you're standing at different corners around the screen, you'll be able to see different perspective into the screen itself in a space. And also, it uses holographic depth effect, which means we'll be designing gameplay where we'll be trying to develop gameplays that sort of revolves around the fact that we are using this sense of depth of the screen. This is kind of how it goes in nitty-gritties. When you're rendering the screen, you're rendering 40 cameras at the same time, which is huge on runtime. And when players or viewers from different perspectives are looking at the screen, you'll be able to see different things. And we started out the question of, we started the project with some of the basic questions, like can we adjust the FOV and the camera settings in real time so that we can fit in the gameplay? And also, what are the in general limitations and what are the general potentials of the device itself? So we try to answer that, and you can't really try to answer that blankly. You got to go into the project. So we built our first prototype. It's the egg flipping experiment, and also with hand tracking. And here are some of the things we learned. First of all, good news is that most of the features like FOV and also the camera lenses, you'll be able to adjust them in real time based on the script that you write. But also, when you're running into things like focal plane, that means the further away the objects are from the focal plane itself, the more blurry they're going to get. And that kind of goes into the art direction later. And also, we figured out something that didn't really quite work well, which is the runtime efficiency of this thing, since I mentioned it's running 40 cameras at the same time when you want the maximum quality. So when you're running that, when you're designing experience for it, you need to be aware of that, and to avoid as many these really delicate physics simulations possible, like egg itself. So with that knowledge, we carry on to our next prototype with some questions, like can we shift the focus of the focal plane by dynamically changing its positions so that we can target different objects as we are going through the gameplay. And also, we have a backup plan for that if it doesn't work, is can we create long tunnels, can we create larger scenes, and render them with the same amount of quality or similar amount of quality without having them blurred out as we're building the experience itself. That's how we headed into Orbit. We went through a long phase of discussion, but after that, we came along with this plan of building a space exploration game that utilized the depth as part of the gameplay so that you will be using that knowledge and apply it to your progression as you are traversing through the game. But what's mainly on the tech side is, first of all, we figured out shifting the focus doesn't really matter. Not that it doesn't matter, but it doesn't really work that well, because as you're shifting the focus plane, it kind of adjusts the FOV plane as well. And thankfully, we had a backup plan of using the long tunnel effect, and by reducing the depth of the overall scene, not to a point that you cannot tell it's a 3D scene or 2D scene anymore, but to a point that you'll be able to preserve some of the 3D effect and really shifting gears in different phases of the game so that you can preserve that illusion of depth when you are playing through it. And overall, the workflow that we're using is sort of like the more you mess around, the more you find out. We build prototypes, we implement them, and through implementation, that enhances our learning. And by applying the learning that we had from the implementations, we loop back to more further iterations through our prototypes. And next up, let's have Lydia talk about the game design.
Okay, so from the beginning of the semester, we've been looking at various types of experience in game and try to select one of them to accommodate into our design. So we look at diving and mining experience on the right side, but basically that's kind of like 2D experience, so we did not choose that. And also we look at some animal mimic movement, which ultimately use player interactions to control the animal movement in natural environments, but we also did not use that. And we also look at farming experience, such as mushroom farm, because this type of game is perfect for the size of the display we have right now, which is just tabletop simulator on your table. So we also look at runner tab on the left. We finally accommodate some of this into our experience because we think object passing through you is a dynamic show of the depth. And finally, we land on the 3D perspective of some objects because we think arrangement of a series of 3D objects in a close range is better and easier for player to observe it. And also, if you place something like the galaxy in front of a screen, it's player intention to tilt their head and move their perspective to look at it a little bit. That's what we want for this product. And we have our current game flow right here. Mainly, we have 2 phases of interactions. The first one is galaxy view, which player will have to observe and then choose a direction to fire their laser beam. And the second one, they will just simply fly their starship along that trajectory and collect the resource. So let's take a closer look at it. On the right side is what you will see as a player when you're entering our game experience, a galaxy view, which you can look at it from the right side and the left side a little bit to observe better path. Because in the interaction phase, you will have to select a path which go through as many resourceful astral as possible. This phase will require you constantly to adjust the direction and distance of the laser beam based on your eye observation, again, to emphasize the depth. And we have our second phase of interactions. On the right side is the flying phase, which you will turn into another perspective following your starship flying into the space. And also you will be able to control the little astronaut outside your starship to collect those resourceful astro. So in this phase, we use the space roaming experience and approach of some very large object in the scene to emphasize the depth of the display. And we also use this visual to showcase the feature of the displays. Now let's hand it over to Cassie to talk about the plane.
So as for our design plan for GDC, except for the dangerous asteroids and the resources, we would like to add more variants for more strategies on observation phase, which will increase the complexity, and this will involve more spatial observation. And for our final product, we would like to implement local multiplayer, such as 2 starships flying together, either cooperating or competing on resource collection. This is because we wanted to utilize looking glass feature of multiple viewers looking at the same holographic object at the same time. And then for our art direction, in our Ghost Spy prototype, we made a frying egg demo to test if looking glass could make the cell shading render object come to life, making innovation to the looking glass display content. But as we tested, we found out that the flat color makes depth hard to discern, reducing the volumetric effect. While in physically based rendering object, the gradient of the material strengthens the depth. So what we learned from this is that the cell shading is not the most compatible style with the looking glass. Now let's have Richie talk into more detail about the art iteration.
Thank you, Cassie. Due to the limited size of the looking glass screen, we also learned to be careful with object scales and the composition of our visuals. One-to-one scale scenes like the frying pan is not an ideal scale because real-life objects can be so big that they block the whole display area. And meanwhile, as Arthur previously explained, objects that float too far off the display surface is heavily blurred and distorted, which means the effects usually done in VR, like things flying by the viewer's eye or head, is not the most compatible with looking glass display feature. So learning this, we shifted our direction to a more miniature-like micro photography style, which is a widely used staging and composition technique found in current looking glass display examples. And going from this, we decided to use stylized, physically based render assets and sci-fi style heads-up display UI in the world space. And this is a design concept of our ship. You can see we are planning to change our astronaut into a extendable robotic arm that can rotate 360 degrees to fit our gameplay better.
So to conclude our presentation, the team is developing a strategic game that requires spatial observation. We wanted to create an experience that relies heavily on the looking glass displays, which will fully utilize the depth. And we will keep polishing the game and then exploring different solutions for the tech. As for the next steps, after Halves, we'll iterate based on the feedbacks and then polish the game and bring it to GDC. And we will reach out to outsourced sound consultant as the team don't have a dedicated sound designer. And then for Spring 4, we will iterate the feedbacks that we got from GDC, and then we will try different solution for the device. And then for Spring 5, which is from week 13 to week 15, we will polish what we got from Spring 4, and then bring it to final. And that's it. Thank you. And we are open to any questions.
So you're working with screens that are designed to be viewed by large numbers of people from different angles, right? How is that informing your design? Because right now I see one player, and then you maybe talked about two player. Are there parts that you're emphasizing that a group of people would want to watch and engage with together?
So the core thing we are emphasizing right now with the design is to encourage people to look at it at a different angle. And in our future plan, we also plan to include allowing two players to view it at the same time to maximize its feature.
I'm trying to build a better understanding of the demo or the game. There's two modes that you view the asteroid field from. Can you talk about how you switch between them and what that user experience is like a little bit more?
What do you mean by like the two modes? Is it like the space view and like it's two?
Do you mean the first phase and the second phase when you're selecting where to shoot and then going and the transition in between?
Correct, yeah.
Yes.
I think so.
So essentially, you start from the kind of like a star chart that you're looking at a whole array or a whole range of stars. After you selected the path that you're going to shoot at, you essentially launch the beam. Then the whole thing will be a real-time cinematic that will be shifting the focus onto the star chart to the perspective of focusing on the spaceship itself. So you basically switch back you switch a camera back in behind the ship itself, and then starts flying forward to a destination.
Oh, and also to add on that, there are two different kind of feeling in these two phases, because at the first one, the player and the galaxy are static belong to each other, and then the other one is more of a dynamic experience for the player.
So for the technology, looking glass technology, what's your opinion on future applications for it? Do you see this as something that could be developed in all kinds of different ways? What kind of future applications do you imagine?
We had a lot of discussion about it, especially after quarters, since the first iteration of it kind of looked like you could just develop this on any other platform. So how we look at the future of this device, first of all, we don't expect it to be as like $3,000 in the future. But development for, I believe it will be mainly focusing on utilizing depth or good designs around this object if it becomes ever popular, is to revolve around the sense of the depth that it brings you. So in some ways, if you can deal with the like some of the blocks, like things blurring out in the distance, long tunnel runners, like back then on Android or on Apple platform when people were playing Temple Run, that was one of the approaches that we utilized every aspect of you can do with a device. In this scenario, I believe, showcasing things, sometimes like in museums, sometimes in mostly a lot of exhibitions that utilize a small amount of space to show you something in 3D and you want to look at it from different perspectives. I think this is kind of the future, how we're looking at what we can do with the device.
So you have hardware that allows the guest to shift their real-world physical position, which then reveals information that couldn't be seen because you're measuring where I'm looking from. Do I have that right?
Yes.
So why did you pick an environment where that ability doesn't really map to a traditional navigation of space? I'm just curious.
By traditional navigation to space?
Flying a spaceship. Because you don't pilot it by tilting your head, right? You pilot it through instruments that measure velocity and all that stuff. I'm just curious, what do you think bringing it to space combat exploration movement amplifies the ability of the display to deliver gameplay?
So currently, from in our iteration, we thought about using head tracking to move around your character in the space, but that was it might take a bit of time.
Why did you pick space in the first place?
I think we picked space in the first place because we started out after the second iteration. We had an idea that we wanted the player to look through a star chart and find a way to go.
Oh, look through a star chart. All right.
Yeah.
And also we want the player to focus on the object instead of the environment.
We want to bring the focus on the object that we're showcasing in the middle, because the focal plane, that it really kind of blurs out things away from it, so it puts a focus on whatever you're presenting basically in the middle of the screen or on that focal plane.
That's time. Thanks, Steve.
Thank you.
Hi, everyone. Welcome to our Halves presentation. We're Team Dream Meow. And as you can see, here's our team. Our faculty advisor is Heather, and our client is Give Kids the World Village. We're working with Encore, who is the Chief Innovation Officer at Wonderlab, which is one of the attractions at Give Kids the World Village. Now, I'll give you some background of our client. Give Kids the World Village. Give Kids the World is a nonprofit organization in Kissimmee, Florida, that provides cost-free vacations for kids with life-threatening illnesses with their families. And one of the attractions in Give Kids the World Village is the Wonderlab. It is a makerspace-style building that have a wide range of activities that aims to introduce STEAM concepts to the children in a fun and interactive way. So initially, there are 3 platforms that we can choose from to build our project. The first one is the Brilliant Spotter. It has 3 Alcon touchscreens, 3 LCD panels, and 3 sets of buttons to create unique interaction with. Right across, there is the puzzle portal. It is a circular room which features a number of wall-mounted steel panels. And in the center of the room, there is a toy bin which houses 3D printed magnetic tracks that the children can rearrange on the wall to create their own courses so that they can drop plastic balls through. And finally here, we have a screen in the hallway and attached to 3 physical buttons. There is currently nothing designed for the screens, for the station, and the screen is simply playing WonderLab videos. However, our client noticed that the kids do like to press the buttons and expect something to happen. Therefore, we also have the options to design a new interaction for this station. When it comes to think about the actual production, there is difficulties to overcome with all these platforms. For example, for the Brilliant Spottler, its uniqueness makes it almost impossible to be prototyped and playtest here in Pittsburgh. As our team skills is more digital rather than physical, it is also challenging to design something for the puzzle portal due to the lack of technology. As for the screen and buttons, it does have more flexibility and fits our team skills, but our client wants interaction that is more physical rather than digital, and anything that's on the screen can be too much like a video game. So since there are pros and cons with all these platforms, we decided that the best approach for us is to research and rapidly iterate as many ideas as possible and to choose based on the feedbacks from our client. And next, Courtney will talk about what we've worked on so far.
Thanks, Michelle. So for the first 3 weeks of the semester, we were in the brainstorming and ideation stage. During this time, our main goals were to understand the limitations and affordances of the available platforms and to generate as many ideas as possible. During this time, we did a lot of research into similar existing experiences, and we also worked with the volunteers currently at the Wonder Lab to understand the needs of not just our target audience, but the people who will be maintaining and running this experience in the future. And based on this feedback, we came up with these 7 design goals. One thing that I want to highlight is that although our target audience is 9 to 13-year-olds, because the Wonder Lab is aimed at older kids staying at the village, it is important that any experience we design can be enjoyed by younger kids as well. The Wonder Lab currently does not have the capacity to support any new activities that require constant facilitation. So in order to ensure we achieve that goal, frequent playtesting with children is going to be a critical component to our success. So this illustrates some of the design iterations that we went through and how we sort of narrowed down our platforms. And this is another illustration of our design iterations. We worked very closely with our client to constantly refine and improve our ideas based on the design goals that we had laid out. And we ultimately landed on our final concept, which will be using the screen with buttons as our platform. So to introduce our final concept, BotMania, these cute little robots that you see are the Wonderbots. They are the mascots of the Wonder Lab. Their names are Wonder, Imagination, and Possibility, or Wan, Mage, and Bill. And part of the lore of the Wonder Lab is that the Wonderbots use it to generate a liquid energy called brilliance, which then powers the entire village. And in our experience, we will be introducing a new function for the Wonderbots, which is delivering creativity to the different characters and the guests staying at the village using their Wonder Rocket. So in this experience, kids will select which bot that they would like to play with, and they will complete certain tasks in order to ensure that the rocket runs smoothly. Each of the Wonderbots have their own unique interests and personalities, and so we've designed the tasks that each bot completes around that. This is a motion-controlled experience, and we have designed each of the activities to use very simple movements to ensure accessibility. We also have a physical component of a physical rocket model, which will respond to the children's inputs. And finally, we have take-home sheets, which, similar to other experiences at the Wonder Lab, kids can take these to learn more about the concepts that are introduced in the experience. And now I will pass over to Melanie to talk about the art and the narrative.
Thank you.
So for the art and the narrative, pretty early on, we were provided a creative brief that was developed by the Wonder Lab staff for anyone who is developing for the space or for their own use. It really outlines the design implementations of the entire building, as well as gives us unique personalities for every robot. So we really wanted to focus on those personalities in our experiences. However, this brief was created as kind of like a loose guide, and anybody who is interacting with the space, they wanted you to put your own artistic spin on it. So we plan to do just that. They also provided us with 3D rigged characters, so we plan to make 3D animated intros to each of our experiences using these robots. Therefore, our experience is going to be 2D and 3D. It's going to be using the 3D models of the characters, as well as 3D models that we create ourselves, and 2D UI elements to use the game system. Since it is motion tracking, this makes most sense with our camera not moving. Later on, or in a minute, Malaya is going to talk about our playtesting, and we chose to do that in a strictly 2D style, and that was just for rapid prototyping before we spent any time on 3D modeling. Next, I'm going to talk about the physical rocket. So this is a paper prototype that we have made. We want to implement it with Arduino parts that would create the ability to make it move and have the kids be able to see whatever they do on the screen has a reaction here. We have made it so that it is take apartable, and we plan to make it 3D printable because the Wonder Lab has several 3D printers on property that if any of the parts break, they can reattach the Arduino parts and put it back together. And now I'm going to pass it off to Malaya, who's going to talk about our first experience.
Thanks, Melanie. Yeah, so now we're going to go through each of the 3 Wonderbots experiences, starting off with 1. So 1 is really into technology, especially circuits. So this experience is aimed to teach kids about circuit basics. Right here is our storyboard for this experience. So first, kids can select and start the game either by pressing one of the 3 physical buttons or by using their motion to select an option on the start screen. Next, the introduction animation will play, which will give some insight into the narrative. And then finally, the actual experience starts. So basically, kids can use their hands and select different nodes in the circuit, and whichever nodes they select will form a connection between them. Based off of the various connections that they make in the circuit, it'll have different effects, such as light bulbs lighting up, or motors spinning, or even short circuits. Once they complete the circuit, the physical rocket in front of them will respond with feedback, such as lights or motion. This is a short video of our first prototype of the game I just explained. We playtested this last week at the CMU playtesting night, and we got lots of valuable feedback there. As you can see, Rushiel's hands are those pink hands being tracked, and then when he hovers them over those 2 nodes, the 2 light bulbs will connect since it's forming a connection. This also works for multiplayer, so kids can work with their families or friends, and like each person holds up one hand and they make connections together. So from playtesting, we came up with improvements that we can make to make it more intuitive, such as making the nodes bigger and decreasing the select time for hovering over nodes. People also really liked the physical interaction and the main game mechanic. So yeah, now I'm going to pass it off to Aaron to talk about Bill.
Thank you, Malaya. So aside from one's experience, we are also working on builds and mages. Bill is an engineer who understands machinery and can quickly find solutions. In this experience, players will use their hand to push the 10-gram pieces into the rocket frame. This isn't just about solving a puzzle. It's about giving kids a fun, interactive way to develop logical and geometric thinking. Even though it's as simple as a 10-gram puzzle, we want the experience to feel more than just completing it. We want it to be playful, like a toy. So instead of just dragging and placing pieces, players will actually push them using their hands. The interactions are completely physics-based. The pieces behave like real objects, following rigid body physics, and the force applied depends on how fast the players move their hands. To make it even more juicy, if a piece gets pushed off screen, it doesn't just appear. It bounces back with a rubber band effect, so the players can move their hands to play around with the pieces, whether they are solving the puzzle or just having fun. After the rocket is fully assembled, the physics rocket model will stretch as a form of feedback, followed by a launch animation. Next, Rochelle will talk about Mage's experience.
Thank you, Aaron. So Mage views the world both logically and creatively. interested in art and technology. She prefers to draft up her ideas using visual communication and color combinations. So keeping that in mind, we decided to make the experience where kids help Mage mix different liquids to form the rocket fuel. And we decided to set it up in a narrative context where Mage is using the liquids from the Brilliance bottler in the other room, and she is combining them to make the rocket fuel. So the interaction here will be tilting these beakers to pour liquids into the bowl. And each of these liquids has a unique property. So properties like thrust power, weight, and fuel efficiency. So for example, let's say the liquid in the bowl is a green liquid, so the fuel efficiency would be 100%. But let's say a kid decides to add the pink liquid into the bowl, then it will increase the thrust power of the rocket, but it will decrease the fuel efficiency. So the total would always remain 100%. And visually, it can be seen as a color combination of the pink liquid and the green liquid, which is in the proportions of the properties. So that will be Mage's experience. And now our producers will talk more about the next steps.
Thank you, Rochelle. So on to our next steps. We've now accomplished the brainstorm and idea part, and we are currently on the prototype and iterate stage. We will have a playtest at the Children's Museum on February 25th, which is tomorrow. This will be a big step for us as we can get the feedbacks from our actual demographic. And our next major milestone will be our playtest at the Wonder Lab. This, it will allow us to get feedbacks from our actual demographic and also allow us to see what our experience is like in that actual space. After that, we'll be refining our experience based on the feedbacks from playtests, and we will have more playtests at the Children's Museum. Our final delivery date is after week 15. That's when we are going to Florida to install the final experience.
So these are the key focus areas for the rest of the semester. We're going to be completing the prototypes for for Mage and Bill's experiences, and then we're going to be playtesting them regularly. We were also going to be working very closely with Ian to ensure the technical design of our experiences will work in the Wonder Lab space, and to create thorough documentation so this can easily be maintained in the future. We are also having a stretch goal to create an alternative controller, just in case there are some kids who can't do the motion controls at all. So, in summary, we are creating an interactive STEAM-based experience for the older kids staying at the Wonder Lab, staying at Good Kids the World Village. Over the next few weeks, we are going to be iterating on our prototypes and refining and playtesting. And then our next milestone is going to be a playtest at the Wonder Lab on March 29th. Thank you all for listening, and we are now ready for questions.
I may have missed it, but did you mention the demographic, how old these older kids are? What's the age?
Yeah, 9 to 13. So these are the characters that already exist in the Wonder Lab. We're using them.
Yeah.
Yes.
And they're for that age group down there.
Yes.
Used for that age group.
Yeah.
Thank you.
It seems like you're fairly long in the design process, but still early in the prototyping process. How are you going to mitigate risk that your designs work?
So I think that's why we are trying to play test as much as possible as we are prototyping, so that way that we can figure out what works and what doesn't very early on, and so that we can constantly improve them.
Do you have any examples of that so far? Of play testing and iteration?
Yeah, so we have the play test that we did last week. Do you want to talk about that?
Sure. Yeah, so we started playtesting last week. We went to playtest night at CMU, but we're most looking forward to, we're starting playtesting at the Children's Museum tomorrow, and then we're hoping to do it on a weekly basis starting tomorrow. So, yeah.
So you talked about some interesting concepts like thrust and efficiency. How are you going to communicate these to 9-year-olds?
So for that game specifically, we would introduce some of it in the animation parts and for a more detailed explanation. So we are planning to have handout sheets, which they already have at Give Kids the World Village, specifically in the Wonder Lab. So if they are introducing, so like let's say in the Wonder Lab they teach kids about stop motion animation, and they have takeout sheets that the kids can take home and learn more about it. So we are planning to introduce concepts and have them like a playful animation style introduction, and then for more details about those concepts, we are planning to add them into the sheets.
Also about the age range, we've talked to a lot of people who worked in the Children's Museum, and one thing they say to us is very helpful is that do not think the 9 to 13 years old as older kids. They're actually young adults, and they are very interested in the thing that they don't know, and they would like to learn it. So I think it's a good thing that we can introduce all these like technical terms to them in this experience.
Okay, so you guys are gonna have a physical rocket, right? Yeah. Is that what? Yeah. Is that what blasts off? I'm sorry if I missed this, but does that blast off, or do they see that on screen? Like, how juicy is the animation, and how exciting is having the physical rocket?
So this rocket is supposed to just be stationary on a counter, and it does have movable functionality to it that we want to implement with actuators. It will animate the blast off, and hopefully the LED functions will mimic kind of like a fire effect, but we're not obviously using real fire. So it's not going to physically blast off, but there will be animation and reactions for the blast off.
This is just something to think about going forward. A lot of time when you watch kids at museum exhibits, they will do half of one exercise and then move on, right? Or a bunch of people together will do different parts of the same one, right? And so I guess I'm wondering, when you're playtesting, you should try to see if you can get some of those experiences too, because people may not be able to see all 3 games being played or to connect it to what's happening with the rocket. So trying to figure out how to make this work in a live space that's not just a clean playtest environment where people are running around and trying things and running to other things might be worth thinking about. So.
Yes, and to kind of go with that point, we've designed it so that kind of kids can choose which one they're interested in and don't have to play all of them. So if you have a kid that's interested in one particular thing, like maybe they're really interested in circuits, they could just play that game and have fun with it and not do anything else.
That's time. Thank you.
Thank you.
All right. Good afternoon, everyone. We're Team Quessant. We're working on a level design initiative for the Rifts RPG universe. Our project aimed to develop a 20 minutes introductory level for a third-person action-adventure game using Unity 6 and the Penguin Action Toolkit. Today, we'll present our progress, including our goals, design decisions, challenge phase, and plans for the remainder of the semester. Big thanks to our instructor, Ruth and Ricardo, and our SME, Couture. So here are our team members. From left to right, Yuhuai, Tianyi, Xixi, Ashling, Albert, Uji, and Lisa. As for our goals and focus of the semester, we want to first design a gameplay based on the Rift's RPG universe. Second, design intuitive core gameplay that encourage exploration and player majesty. And third, provide players with guidance for better player experience. We plan on achieving them by first, narration and arts that follows the Rift RPG IP. And second, level and game design. And third, beats and UI designs for guidance. The IP we're using for educational purposes is Rift's tabletop role-playing game, which is set in the disaster-struck Earth where magic, advanced technology, and creatures from different dimensions coexist. For our design, we choose to work with the content from the England Magic Worldbook. The England world in Rift sets in a magical forest land where locals battle against bad forces, with lost ruins shape the factual world. As for our story will focus on a magical hiding coalition soldier drawn to a mythical world by the call of the Millennium Tree, ultimately embracing magic and battle it for the greater goods. Our level will focus on the earlier stage of the game, which is about a coalition outsider discover a hidden connection to nature's energy, granting her the power to purify a corrupted blood druid's altar. As she masters her newfound ability, she fights alongside the druids, battling undead and the dark forces. Now Albert will dive into our levels.
Thank you, Ashley. So the protagonist of our game is a coalition soldier who learned the druid magic along the way and helped druid to purify the corrupted altars. And the core gameplay of our game is casting. So the player uses spells to jump across platforms, solve puzzles, and also take on enemies in combat. And the wood magic allows both the attack and also the creating a barrier, and also the wind magic allows the player to push and pull objects in the environment. So during the exploration of the temples, the player have 3 goals. The first one, which is also the main goal, is to purify the altars and weaken the blood druid. The second goal is to unlock new spells to progress. And the third goal, which is also a side quest, is to rescue the captured druids hidden in the temple. And this can enhance the maximum energy of the player. So now we are going to walk through our current progress with a lab demo. We start with the game's main menu where selecting new games take us to the loading screen, which provides hints on spells and background lore from the Rift universe. At the beginning, the player falls into a cave. While exploring, glowing mushrooms are discovered, restoring energy and introducing the concept of collectibles and resource management. While navigating the cave through jumping, climbing, and dashing, the player encounters a druid NPC who provides story context and guides the journey to the first altar. Interacting with the altar unlocks tree magic, a core spell used for both combat and traversal. The UI then introduces the level 1 spell is a basic attack, and the level 2 is the tree wall. And level 2 spells always cost energy. A nearby checkpoint allows the players to save progress and restore energy. In this game, the player's energy is also their health, so players need to manage their energy properly. After learning tree magic, a platforming section begins where tree walls are used to reach higher platforms. And as you can see, for the wider gap, the player needs to use jump dash. Progressing further, the player encounters the first combat arena, where minions must be defeated using basic attacks and the level 2 spells. Reaching a vista point, the player gets a preview of the main scene and their next objective, the temples. Since the game's protagonist is a robotic soldier from the Coalition, we incorporated more electronic and high-tech elements into the dash effect. Since dashing is the most frequently used action, we wanted to make sure it looks visually appealing. Moving forward, the player encounters another checkpoint and enters the first temple, Wu Temple. The player's goal in entering the temple is to find the hidden altar and unlock new spells. Along the way, they can also rescue jewels hidden within the temple to increase their maximum energy. And by stepping on the trigger, the player can move certain platform inside the temple, and the yellow bar gives the player the capacity to jump up. And here's another smaller combat arena. Yeah, so for this one, we might need the wood trunk to help us. Before building the actual levels, we created a playground level to test game mechanics and level design style. After some testing, we kept certain elements from it and incorporated them into the formal levels. And now, as you can see, the blue platform represents the platform that can only be moved by the wind magic. So for now, we don't have that. So let's find the wind altar first. And the trigger on the wall can also be touched by the wood magic. Yeah, now we see the second save point. So the save point helps the player to restore their energy and also save the progress of the game. Oops. Yeah, so there is the wind altar. So after interacting with it, the player unlocks the wind magic, which is level one. The level one magic is to push, and the level two is generate a wind ball, which can drag the object around it, like this. And also, the enemies can also affected by the wind ball. Yeah, yeah. So in this room, there are big walls that can be pushed. So by pushing this wall, the player can discover a bigger space and also step on those triggers. And now the player find their way to return the central area. And that's it for the progress we have for now.
Thank you, Albert and Wuji, for the live demo. Now let's go over our level development progress. Since you've already seen some scene in the level, I'll keep this brief. This session introduced core mechanics, introducing jumping, climbing, dashing, and magic-based combat. Player meets your first druid NPC, the first altar, unlock the tree magic, and practice combat before reaching the bonfire checkpoint. From a development perspective, we've fully implemented mechanics, UI, and combat. Next, we'll refine visual, polish terrain, and optimize some game balance into the scene. In scene 2.1, the wood temple, player engaged with the puzzle solving for the first time, using pressure plates, switches, and buttons to navigate the environment. Combat also expands, requiring players to combine movement and casting spells. At the end of the temple, player will encounter and purify a second altar to unlock wind magic. The wind magic spells allow players to push or pull objects based on their cast. They must now combine wind and tree magic to solve puzzles and return to the bonfire, which serves as a game central hub. The wind temple shifts the focus to elevation-based puzzle, requiring players to push or pull objects to reach new areas. Combat also evolves, with enemy reacting dynamically to height changes, forcing players to adapt spellcasting and movement strategies. Exploration expands in this session as players can rescue druid in hidden places to gain energy boost. We finished the paper design and our next step including building gray box and implemented spell-based interactions. The final sections of our game culminates in a boss battle against the Blood Druid, requiring players to combine everything they've learned throughout the game. This battle serves as both a mechanical and narrative conclusion for the player's journey. Next, we'll develop boss mechanics, refine AI behavior, and enhance combat pacing. And with that, we've covered our level breakdown and development progress. We're excited to keep refining the game and look forward to feedback.
Yeah, and here I'm going to talk about the skills in this game. Like, our character skills are separated into two types, the basic skills and the magic spells. The basic skills are actions that you can perform from the start of the game without unlocking anything. Narrative-wise, those are the skill sets that our protagonist brings from the collision world, and that makes her different from the other character in the game. For example, like the energy exchangeability, like change any collectible into electricity to drive the character since she's a cyborg. And the dash is decorated with sci-fi elements and magic element to better enhance their identity. In the aspect of level design, those basic skills constructed the fundamental element of the game as they exist from the start. For example, the edge grab allows more horizontal design, which can better portray the world we are building. The energy converts guide the player with collectible, so they will explore the level in a more intuitive way. The dash boost, which increases mobility, but it also allows some spacing puzzle design to be available for the design.
So now let's take a look at our spell system. The spell is very important in our gameplay. It's used for combat, for puzzling, and also for platforming. There are 2 levels of our spells. The level 1 serves as the basic ability of the player, and the level 2 is more advanced. It costs energy, but it's more powerful. So let's take a look at the level 1 with magic. It serves as a basic attack for player to combat the enemies. And for level 2, it's a wood attack, it's a wood wall. Player can use it to cause a large amount of damage to enemies, and the player can also use it as a platform for them to jump. And for the wing magic, the level 1 is a shockwave. Player can use it to pull and to push the objects and creatures away. And then it can also be used as a counterattack. Player can use it to block the attacks from the enemies. And the level 2 wind spell is a wind ball. It can drag other objects and the creatures. You can see from the GIF. And it can be used in many puzzling and combat events based on how players use it.
Okay, so now let's talk about the art direction. So basically, we made a coherent art direction based on the IP itself, and also we prepared a color palette to indicate about the different emotions and interactions for players. And after iterating, we decided to change our whole environment more reddish to create a feeling of anxious for the player. And for the 3D art asset side, besides some exterior asset packages we already bought in Unity, we also made some iconic hero assets based on the reference pictures in the book, such as the big brain tree and the small mushroom used to restore energy. And also we made some alien insects living in these world settings. Since our gameplay will involve a lot of the puzzle solving parts, we also made some triggers with emission totem for the players to interact with. And in order to make the player experience much better and have clear guidance, we implemented various functions UIs into our game, such as the tutorial UI or the UI for interactable hints. We also included dialogue and narrative UI to help the players better understand the world settings.
And so, before Halves, we have conducted multiple playtests and carefully document our feedback and iterations. And this process helped us refine our gameplay, balance our combat, improve the navigation clarity, and also enhance the spatial awareness for our level. And we also want to extend our gratitude to all the players who have tested our games, as well as our answering tool for their invaluable feedback. And here's our timeline. So in detail, our goals after Halves is on finalizing the first scene's visuals, the building and testing the wind tempo, and developing the final boss fight mechanics. And looking ahead, by week 10, we will try to finish the asset integration. That means replacing most of the placeholder assets with the final art and sound designs. And by week 12, we will conduct thorough playtests to identify any remaining issues. And after that, we could prepare for the final deliverables. So with these goals in mind, we are ready to deliver a fully playable level by the end of the semester. And that's it. Thank you. We're open to questions.
Thank you. What do you think the main identity of your game is? What makes this game unique?
Our focus is to create a narrative-driven puzzle-solving game that's very focused on the Rift's RPG universe. So we not only want to make this game fun in the puzzle-solving aspect, but also we want to focus heavily on the world building itself.
Okay, thank you.
Is Quessant, is that a play on croissant? What is that? What does the name mean?
So that name is the name for our team. It follows with a tradition of, so all the past level design production has the word quest in it, so we just integrate that into our team name, but that's not going to be the name for our game.
Could you talk a little bit about the use of the Penguin Action Toolkit and whether other people used it besides Penguin Action Toolkit developers? Or I'm just curious. It wasn't built for Unity 6, right? So you had to do some tweaks to it?
Actually, like over the winter break, I test a little bit how to integrate to Unity 6, and it turns out all I need to do is just to upgrade the Cinemachine virtual camera. So yeah, it's working with Unity 6, like without with only a few changes. In terms of collaboration, since like we don't. Like our team didn't want to spend too much time just to learn how to use the toolkit, so I'll be taking a huge part about how to build a penguin pet character. But like I still collaborate with other programmers. By the other programmers will make some basic skills, and I'll just make it inherit something we call state modifier to making a character skill. So yeah, like we still kind of works together.
So several times you've said that you want your game to be narrative, and right now I don't have a sense of like what is the character's like personal journey and how does that reflected in the level that you've designed, or aside from like the fighting and the collecting things, like where is the story coming through in the level? Does that make sense? So I'm sort of wondering if you can fill me in on the narrative stuff that I'm missing.
Yeah. Thank you for that question. And yeah, so as for the gameplay, right now we're planning on doing a 20 minutes gameplay, so that will probably not tell like the entire plot of our story, but we are thinking about, other than making the level fun, we are thinking about solving the narrative aspect by implementing UI with dialogues from like interaction with NPCs. And as you can see during the lab demos, when you first wake up in the cave, there is this druid NPC that talks to you, and the dialogues is going to be in charge of most of the narration aspect. And as the player walk along the levels, they will not only find one NPC, there will be a few more talking about it throughout the gameplay, so that player can better understand what the story is about behind this level. Thank you.
So is the uniqueness in the story, in the story narrative, or in the technology you're using to create the game? What's the unique? Following up with Mo's question about what's unique about it.
So you're asking, are we focusing more on the level aspect?
What makes this game you're making so unique? Is it the technology, the Penguin toolkit you're using, or is it the narrative you have yet to create?
I think it's more towards the collaboration with the Penguin Action Toolkit. Of course, like we haven't tested, there wasn't much game built based off of that, and the narrative aspect is something unique for the level design production project specifically. Like we want to tell more stories about it since we are already based on this universe. So we were trying to think of multiple ways of implementing storytellings inside as well. Yeah.
And one word I would like to quickly add on is we choose this England word book that is special for magic, and it rarely happens in other word books of the Rift's universe. So we picked this world for a player to cast spell, and the casting is a really important verbs in our player's journey. So compared to other level design production initiatives, our game probably will more focus on revealing the story of a magical world, and also let the players to cast different spells as a cyborg.
Thank you. That's time.
Microphone test. Mic test. Test, test.
Okay, cool.
Okay, so hello, we're Hello Alice, and this. Oh, I didn't take the clicker. No one takes the clicker. Can I restart, please? Thank you. Okay, so again, hello, we're Hello Alice, and this is our half presentation. So I'm Eva, this is Yifan, Jingyi, Jia, Zhanqi, and Wendy, and our project instructor is Dave. And we're working closely with Melanie and Daniel from the Alice team. So at the beginning of the semester, we're given a mission. We're reimagining coding education beyond dragging and dropping with AI assistant for 10 to 12 years old in a classroom settings. This seems like a lot to think about. So to approach this question, we divided it into motivation and execution. Our goal is to create an experience that supports students to explore programming and also encourage them to create something that is unexpected. At the same time, we wanted to ensure that there's a strong execution that supports and enhances their motivation.
So with this goal in mind, we started our research. We looked at how coding education tools work today, including Scratch, Scratch Junior, and of course, Alice. All of these use block-based programming with drag-and-drop interaction as their teaching method. This approach makes learning easier and helps beginners avoid errors since they don't need to understand all the details of the code to start building. We also explored how AI is being used in coding. There are many tools that can generate code for you. For example, Roblox AI has a ChatGPT-like feature that provides ready-to-use code for the Roblox editor. However, this isn't the kind of in-game AI experience we have in mind. Then, our team started brainstorming and came up with 4 different ideas, each exploring a unique approach. When we presented to the client, we realized that both our team and the client favored concepts that focus on high-level thinking and creativity, encouraging students to think beyond just writing code. Some pitches fell short due to complex interactions and interface challenges, while others were too limiting in the actions students could take. So, our goal was to ensure that students feel empowered and have the freedom to express their creativity fully.
So our solution is a natural language and AI, which aligns with our goal. At this point, you might wonder, why natural language? Let's go back to the limitation of drag-and-drop programming. While simplified coding is still focused on low-level ideas, you need to understand variables, logic structure, and how to piece everything together before you can achieve your bigger goals. Take Alice 3 as an example. If the player wants to make this rabbit say hello, they'll have to figure out the print function and possibly an if condition to trigger it. So this requires thinking about how to assemble the code components rather than focusing on their creative ideas. Natural language, on the other hand, allows them to start from a higher level idea. They begin with the creation process, with having an idea in mind, describe it in natural terms, and let AI handle the breakdown. The AI then is translated into lower-level code components, making the idea functional. This helps them visualize their thoughts and also create more opportunity to learn computational thinking. Now, if AI is doing all the coding, how will students learn programming? The goal is to have the code be shown in code blocks to make it more readable and understandable. And along with that, students can always have the chance to see the original code. As they gain understanding of what the logic is, they will then be able to make edits and learn the programming language and concepts. So our solution is a tool that
that allows the users to interact using natural language with AI assisting in generating code to build an interactive narrative. This allows them to focus on creativity. Players express their idea using high-level natural language, describe what they want to happen in the scene. The AI then translates what they want into low-level code, handling the technical details. This loop continues, allowing them to build an interactive narrative. Now let's take a look at what the tool is like.
Thank you, Eva. Now, Ethan and I will show will show a live demo. So imagine I am a 12-year-old kid, and I'm going to use this tool to create a very simple story. And first, I need to pick up a scene to start with. And you can see here we have the Alice Forest and the Alice Castle. And I think I would like to start with the forest. Whoa. So now it seems like I'm a little knight walking in this enchanted forest, and there are some trees and mushrooms, and I'm not very sure what to do next. But since I'm a knight, I guess there's a very clear quest for me, which is to find the princess. I think the magic tree here can tell me where the princess is. So let's ask it.
So back in our queue, now we are at the playground mode. So this is where you can use voice command you can send your voice command to AI to generate code for you. So here we want to bind a dialogue to the tree. So we can hit the speak to send the request to AI. Tree, where's the princess? And we can hit submit. It will generate the code. Sorry, let's try again. Tree, where's the princess?
Yeah, the tree tells me that the princess is not here, but I might find her in the castle. And then I think I need to find a way to the castle.
So back to the tool, we can bind the interaction to the tree. So we can switch to the interaction thing and select the tree and hit add to add the interaction we just created to the tree. So here we can set the interaction trigger for it. Let's do press E, and we can add the interaction to it.
Well, and now it's my time to find the door to the castle. Well, the large yellow mushroom seems very suspicious. I think if I touch the mushroom, there might be a secret door to the castle. So I want a door there.
So we can go back to the playground mode and make a door. Sorry. Make a door. And hit submit.
Yeah, I like the door. I like the color and all the decoration. It seems like the secret way to the castle. And then the last thing I need to do is to let the door take me to the castle.
Okay, so we can add a new script. Take me to the castle.
Wow, that's cool. And since I finally have a way to the princess, I think I may feel very happy and lucky. And I also want to add something to show my feelings.
Yeah, so since we are using ChatGPT, it can take very arbitrary commands. So I feel lucky. Yeah, and it will play a cheerful sound. And in case you're interested, we can hit show to show the code that's actually being executed. You can save it and go back to the interactions thing and bind all the interactions we just made. So first, we want to add a spawn door interaction to the mushroom. So this time we can hit F, add the spawn door script, and we can hit the green button here to preview the door so that we can add interaction to the door that's spawned in at runtime. Hit add, and If press E to interact with the door, we can travel to the castle and hit save.
And now let's play my game.
Okay, so then we can go to the playground mode, so we can actually test our story flow. So we are now in the forest, and we can talk with the tree. The tree said princess might be in the castle, and since we already know the secret door is hidden under the mushroom, we can interact with the mushroom. It will spawn a door, and if I interact with the door, I'll be teleported to the castle.
Yay! But I feel quite lonely in this game. I want another character. So who want to be the character in my game? Anyone? Okay, Colin, do you want to be in my game? Okay, let's create a character named Colin.
Create a character named Colin in the game. Oh, Craig. Let me manually fix that.
Yeah.
Great.
So if the voice detection is not very accurate, we can use typing to correct it.
Okay, and hit submit.
Oh, Colin, you are a yellow cube in the game. Yeah.
It's underground.
It's very small. We can try it again. It's okay. We can try it again.
Yeah, we can try do it again.
We can reset it and try it
submit
again.
again.
This time
Hi,
you are
I'm
red
Colin.
cube. Hi, I'm Colin.
Okay, and that's it for our live demo. Click. Okay, so as we seen in the live demo, our tool is divided into 3 key components. The first one is the playground mode. It is where we use our voice command to send requests to AI and get the executable code blocks. And the second one is the interaction editor. It's where we bind the scripts we created to actual objects, so we can interact with it and create our story flow. And finally, the playground mode. It is where we can have our deliverable of our tool. It will be a space to explore, and it can be a space to test out the interaction and story flow you just made, and for other players to explore.
And we first try to allow AI to use all of the C#, Unity C# method to generate code, and actually it worked very well. But later we realized that we should set constraints to AI for a more stable output and better code visualization. So now we are having AI to only generate the Lua script instead, and choose to expose some of the Unity methods to AI. For this method, we create very clear code blocks for our users to get a better sense of what is going on behind AI. This leads to a more controllable result and ensures a balance between the creativity and the structure.
For the art workflow, to ensure a smooth workflow and the consistent art style, we structured our pipeline into modeling, texturing, and building scene in Unity. This approach streamlines development, as our goal is to create a diverse set of art assets that inspires players, giving them more elements to experiment with.
In terms of art style, we reference from the Alice stories, a globally renowned fairy tale loved by children for its quirky narrative styles and visual appearance. As AI has the strength in creating things that is interesting and sometimes weird, Alice is the exact thing that can support, making Alice as the choice of a design style. For the prototype one, we developed 2 simple things for the kids to start with when they first entering the world. These scenarios can motivate kids to start with doing something instead of giving a blank world where they might be confused about what games or story to create. And this can also benefit our artists by limiting the numbers of assets needed.
So what are the next steps? As the technical foundation of the tool is in place, we're going back to the motivation question. What makes the kid want to build a story? To explore this, we wanted to look into 2 different factors. If it's seeing a story, then should we provide more visuals? If it's given a prompt, can ChatGPT help us do it? We'll explore this with our future playtest plan. To connect better with our target audience, our playtest pen focus on understanding their motivation. We'll provide a list of art assets and a blank storyboard to see how 10 to 12 years old start building a story. This will help us know what inspired them to start and also what we can do in the process. We vision that through iteration, our final deliverable will be an experiential prototype that is the foundation of what Alice can explore in future coding education, and will be suitable for a classroom environment while having guidance from instructors. So to sum up, our vision is to reimagine coding education beyond dragging and dropping with AI assistant designed for 10 to 12 years old. We're building a programming educational tool that leverages AI, enabling users to create their own 3D world using natural language command, making coding more intuitive, creative, and accessible. Thank you for your listening. We're open to questions.
So I'm sure the 10 to 12-year-olds are really rewarded to see the output, to see it run. Are they going to be rewarded to look at the code? Is there any way you want them to look at the code and maybe change the code to see a change in execution?
Yes, of course. That's what we are planning to do after Halves. So now they can only use the code directly generated by AI. And after Halves, we are planning to make them be able to edit the code blocks created by AI.
So it was clear from your voice input, right, that it has trouble sometimes understanding what people are saying. That could be an issue with populations where people are not speaking necessarily like proper American or British English all the time. So one, I have a question about that. The other one is, even if that's the case, have you tried making really weird, surreal things just by seeing what it does, and is that also fun? So two-part question, sorry.
So for the first question, that's why instead of using voice recognition, we use the term natural language, because our tool also supports typing in. So in case the environment is too noisy or people is not like that good at speaking English, they could still have a way to play around with the tool. And for the second
question, we've playtest this tool with some very random ideas. For example, we can let AI to create a character, or we also tried some very wild commands such as, I want a stage here, or tell me a story about a wizard. And AI will generate a scene, will spawn some object and add dialogues according to the models we have now. So the limitation to AI now is the art assets. So after Halves, we are planning to add more art assets, and the AI will be more smart. Yeah, will be smarter.
Have you run into any problems with the AI generating problematic code or incorrect code or buggy code?
Yeah, so we have a retry system. So the first time, if the code cannot be executed, we will retry for another 2 times. And if it failed, it will tell the user that, sorry, we cannot handle this request.
When it tries it the first couple of times, does the user see that happening? Or is it only just the dialog box saying we can't do that?
It will just pop up window says, sorry, we cannot do that.
Okay.
I feel like this has probably brought you all closer to the world of AI-generated code. Is anything you're experiencing on the project so far changing your thinking about how we're likely to be using AI as part of the coding process in the future?
I think for this project specifically, because we need to create a narrative experience. So sometimes our users don't have a very clear ideas about what they are going to create. For example, they just want the tree to tell me where's the princess, but they don't know the detailed dialogue, or they they have no idea about what the tree is going to see. So for our project, I think the advantage of AI is that we can provide a quite high-level request, and AI can break down into very low-level execution, and also it will, because we are using OpenAI API, so it's very good at natural language processing, so it can help the user to add more details to their story and ideas.
Thanks.
Okay, that's time.
Thank you. Thank you.
We have 4 done. This is our break. We can stretch, we can move around. Let's try to restart though at 4:30. Let's do a 6-minute break. We'll get back. Masking tape on the bottom, and it's like, that's the bad one.
This one dropped the bar, so I'm going to replace it. Because they're all talking.
Yeah, 2 minutes. We're going to get started in 2 minutes. 2 minutes, 2 minutes.
No, they're last. But still, I know they're here. Yes, yes. And stand up to see it. You need to see like. Yes, I think. Oh, this one looks like it didn't come from. This looks like it was either dramas, or they went to the. Yes, yes. Or they went to thrift shops. They were torn. But they'll show up.
Expression, you here?
We only have one? Okay, two.
All right. Hello. So let's start. Hello, everyone. We're Team Expression, and we are here to present our Halves progress for the project Freedom of Speech and the Inclusive Campus. So our team, as an introduction, I'm Luton, and this is Jack, Mo, Kylan, and Jiwon. And our faculty advisors are Brenda and Rolf. For our subject matter expert is Richard Shines, who is the Dean of the Dietrich College of Humanities and Social Science. So as a, Okay, as a project overview, so our game is trying to create a narrative-based dating simulator which shifts the CMU students' perspective on the free speech on campus by educating them on its legal, social, and academic aspect. So for our audience, they are incoming CMU students, and they will get access to our project through either through the CMU orientation or potentially through educational material on their classes. So today we have 4 aspects to present for our Halves progress. They are legal research, transformations, narratives, game mechanism, and production milestones. So first of all, let's start with our early research on the transformational goal for this project. In the beginning of semester, we had a discussion about our project objectives and legal information with our SME, Richard Shines. As a result, we narrowed down our research focus and project objectives into 3 aspects that enforce the free speech on campus. First of all, it's the law, social norm, and finally the CMU policy. To be so specific, we want to focus on the legislative influence of the US First Amendment and how different cultural and social backgrounds, they kind of build different notions on the free speech topic. And finally, how the CMU policy uphold the First Amendment while still protect students' academic freedom at the same time. Besides the concepts, so we also want to focus on how the examples and some real-life court cases does educate the audience to identify what are the protected speech and what are not. So the major difference between the not protected speech is, so basically non-protected speech are typically contains a harassment and actual violence. For some example, they are typically including the obscenity, true threats, fighting words, and fraud. And for the protected speech, they are typically the expression of an ideology or like a certain belief. So typically, for some example, they will contain the political and religious speech, art, and also protest. So also on the same side, like why is the hate speech protected? Because despite its content is offensive sometimes to people, it is still unlikely to incite direct violence. So therefore, it's still part of the free speech illegally, and it can be subjected to any legal actions. So we then talk about the transformational goals.
Okay, so for our transformational goals, we want our players to go from the initial stage of oblivious into the transformed stage of informed, and go from thoughtless actions into having a more empathetic worldview. We actually made this survey to CMU students, where we found out that indeed a lot of them are not very familiar with free speech, but even less with the US laws regarding it. We also found out that most students do care about free speech, that their biggest barriers are complexity and fear, and that their comfort varies from when sharing their opinions in social media, where it's really low, to friends and family, where it's really high, or in an academic setting, where it's mixed. So why do we think that a dating sim would work for this topic? Basically, a dating sim makes this serious topic more approachable while being appealing to younger generations. Dating sims can have an extensive storyline, but usually in the form of natural dialogue, which would make the topic more digestible. And also, dating sims excel at emotional engagement while creating a safe place for our players to explore and practice free speech in a low-stakes setting. We believe that this emotional connection can empower students, encouraging them to overcome their fears and complexities regarding this topic.
So here's the interesting part, the narrative. This game is our major inspiration. The monster prompt contains various characters that can actually date with. And our strategy is to personify these complicated and abstract concepts into real human beings that you can actually interact with. So the players will be driven by a natural motivation that you want to know who they are and what their lives are going on. And through this process, they will be able to learn the knowledge unknowingly. So introducing our characters, ta-da! And this is Law, and we decided to call him Lawrence. He'll be like very strict and rigid points of view he has, and he has a very serious personality. So we make him like very squarey and pointy and long. And based on the First Amendment, due to its relatively lenient nature, he'll take a neutral stance on various forms of speech. However, if you cross the red line, he'll show his harsh side. He knows everything about law in our narrative. He'll be responsible to explain the players about all those concepts about law. Based on the classic figure of law, we decided to give him a sword, which is a bit of weird, so we decided to put him in the fencing club to justify why he is always carrying a sword around. Yes, CMU fencing club. And this is our favorite, the social norm, Norma. And the reference of social norm, Norma, is Glinda, Disney princesses, and Heather sisters. We are thinking she will be very charming, likable, and popular. The reason why we are setting her as a very popular character is because concept of popularity itself is tightly linked to the norms. There will be certain formula that builds a person popular, like what to dress, how they speak, and how to stand. Like Glenda said, it's very shoot to be, yes, and she'll be a little bit manipulative. And I just thinking like, if the society is a huge test, this girl, oh, no, without doubt, she'll like score A++ in this test. And we're making her glamour into the stars, like the tiara surrounding her head. Like, we think it will be very interesting, like when she's getting mad, the stars will burn. And if she's like trying to charm other people, the stars will sparkle very hard. And this is CMU policy. They are probably the easiest to design, is because like there already exists like tons of elements of the policy, right? Tons of elements of the Carnegie Mellon University, like the classic black, red, and green palettes, and the Scottish skirts, and the Highland pipes. And their name is Polly, and they will be very knowledgeable on CMU and cares about other students. And we're setting them as the stepbrother or sister of the law, for the policy is based on the First Amendment itself. It's basically the First Amendment / the school rule. So we think it would be very intuitive to make them relatives.
Okay, so for the incidents, we're introducing them into 3 hypothetical cases. The first incidents incorporate the heckler's veto and hate speech, as it can unfold through a controversial statement made by a guest speaker. This statement sparks discussion about the characters driving their narrative forward. And for the second incident, it uses trigger warning in classroom as a starting point to explore the entry point to explore academic freedom, highlighting the complexity of freedom of speech within the academic setting. And the third incident introduced the character's fear and self-censorship, serving as a lens to examine the tension and balance between law and social norms. So as for our structure, this table outlines how the stories are distributed throughout the game. The game spans 6 days, with events occurring each morning and afternoon. After the 2 main incidents happening in the morning and afternoon, there are also some side conversations and side story happening. In the evening, there's also a write report feature, which is used for players to review their knowledge they learned in the morning. And the detailed feature will be explained in later slides. So currently we have 2 dialogues written already, and the third one is still in progress. Moving forward, we plan to refine our dialogue and the narratives through playtesting and iterations. Next, I'll hand it over to Jiwon.
Yeah, so I'm gonna talk about our game mechanics. The 3 major game pillars include character interactions, campus explorations, and review learnings. I will further explain them one by one with our progress images. So first, character interactions. So the player can proceed the 5-day with conversations that are relationship focused and also containing informations related to freedom of speech and academic freedom. So there are 3 pursuable characters in the game and also other NPCs to talk about trivial talks and also fun facts about CMU. And also the player can participate in forums to discuss major incidents happening in campus. So depending on the choice, the affection progress for each pursuable characters will go up and down. So this is the major gameplay for our game. And campus exploration is our second game pillar. So this is where the player get to choose where they want to initiate the conversation with the NPCs or the pursuable characters. They can mimic CMU, the map is, we try to mimic the CMU campus map, and these buildings include auditorium, Dietrich, Fence, College of Fine Arts, and Hunt Library. So the players can encounter 2 major incidents in 2 buildings a day, and also there are 3 subsidiary talks that are initiated with NPCs. At the end of the day, they can review what they have learned during the day. So they can swipe keynotes every day with their phone, which is implemented as one of our system in our game. And also we want to make it really approachable and easy for player to learn, because we don't want to bore them with like a wall of text, since our subject is a little bit maybe boring for people. So we wanted to organize this card news in organized and simple form, and also make the player solve a mini quiz about what they have learned during the day.
Next, I'll talk about the phone system in the game. The phone system will be integrated throughout the gameplay, including the dorm and the map view. There are 4 main parts that we want to include in this system. First is the affection, where players can check each character's affection status. Next is the recap today, where players can do the review study that has been explained in the previous slides. And then comes to the profiles of the character, providing players with more information about each character. And lastly, there's an online forum where players can see people's reactions online, such as discussions about fence painting. And now I'll introduce the daily basic game loop about the game. The purple sections are the time periods divided into morning, afternoon, and evening. And the green sections are dialogues, while the yellow sections are the interactive elements in the game. First, the player will start in the dorm, and then with engaging in some self-dialogue with backgrounds and some details. After that, they'll enter the map where they can choose a location to go to. And both in the dorm and in the map, the player can check on their phones, which related to the phone system. And then upon entering an isometric location, player can either interact with the interactables or proceed to the main incident. Interactables include NPCs that can trigger small talks, or like objects that, posters or magazines that provide extra information about either CMU campus, freedom of speech knowledge, or character insights. And on the other hand, player can only progress into the next time period through the main incident. If the player is progressing from morning to the afternoon, they will return back to the map and then start the loop, go through the loop again. And if the player is progressing from afternoon to the evening, they will return to the dorm, and then after finishing the review learning, the day will end. And this is the basic daily loop of the game. Over to Kylan.
So for production, our project success rely on 3 key factors, which is being informative, entertaining, and accessible. We aim to inform player about free speech through engaging gameplay while having a broad accessibility on campus. So currently, we're progressing in 3 areas: the research, game development, and SME consultation. We have conducted research on free speech, including case studies, legal framework, and CME policies. And we have consulted subject matter expert for deeper insights. On the development side, we are working on art, narrative, UI design, and gameplay design. And for our next steps, we will go for legal consultation while continue to develop on narrative, art, UI, and gameplay. After the week of GDC, we'll start on sound effects, refine user interface, etc. And we will iterate based on the playtest in the future. We'll also have planned a buffer time before solves for any necessary fine-tuning. And as a conclusion, our deliverable is a transformational game demo about free speech, and our target audience is incoming CMU students. Thank you. We're open for questions now.
Oh, hello. I just had a question about your characters, just because I know in a lot of dating simulators, often what happens is you're essentially forced to, in certain situations, to choose between 2 different characters who are both sort of options in the game, but might be in conflict at that point. So based on your research, what are you imagining are the kinds of potential conflicts that would force the player to choose between, say, law and social norm, or like social norm and CMU policy?
So we were thinking about that when we were having our narrative meetings, and we were thinking of the idea of having all of these 3 characters be in the school government, and the player has to help all 3 of them in their free time in one problem that they may be having regarding opposing views between them. So when you give your support to a certain character, you are gonna like win them over and get more affection from them.
So my biggest question is, it seems like the incidents are like the most important part in teaching CMU students or players about free speech. However, how are you going to connect that to the dating sim progression of it? Like, are you guys thinking of perhaps with the characters that you guys are favoring throughout the game, will the incidents resolve themselves, or have like a different possible solution depending on if you're favoring social norms. Like for example, like how is the dating sim, the progression aspect of the dating sim gonna change the other aspects of the game? Have you guys thought about that?
Yes, because at first we weren't sure if we wanted to go full on with the dating narrative for this game, but in the end we decided that we want this game to be transformational and to like have a hook so players want to play it. So we will definitely focus on the dating sim part, and we're still thinking of ways to, I guess, combine this with the narrative we already had planned. Because so far we were thinking that the narrative was not going to change throughout the week, and it's only going to change in the last day where you decide who you're gonna date, or the ending would be that you end up with one of those 3 characters. But we're still thinking on how to move our narrative to, I guess, mix these 2 topics together well.
Yeah, we have a few discussions on like the aspect you talk about. So like currently we are thinking about like the preference accumulation system. So like for each day, if you interact more with a certain character, and at the end of the day, you will have more report about this character's information, as well as you can keep on track of their progress on your phone, and you can also text them to go out and for a certain like a small incident after you complete some like major line throughout the day. So we will definitely implement something incident like that, like specific for a certain character. But also considering the scope-wise, we would now like maybe narrow down into like only Saturday, which is on the final day. We will have like dating incident with them. Yep. No.
Another interesting fact that we didn't mention in the slides because we already built the relationships between these 3 characters based on the reality itself. Like we're thinking like social norms is kind of like constantly wants to change the law in some way. So they'll have a kind of like tense relationship between these 2. And the policy will be like, because it's based on the law and also the school rules, so they will be like probably more close to the law, maybe in kind of sense. Yeah, and we are trying to probably solve these conflicts between these 3 concepts because they're like very dynamic. It's very interesting to discuss, and we are trying to put the players into a situation to see how they interact with each other, and then to see how the story goes on.
That's time, unfortunately. That's time. Thank you, guys.
Do you want us to just... Hello, we are Team Onion Future, and here's our presentation. I am Michael, this is Colin, Derek, Ian, Nina, and Chunyi, and here is a demo of our progress.
All right, so what is our project? We are trying to make an RPG on this device, the Playdate, that takes advantage of its unique controls in as many fun and intuitive ways as we can.
The Playdate is a small, independently developed handheld console. It was made by Panic and Teenage Engineering. Like Michael mentioned, it tries to iterate on the classic handheld design with the face buttons and the D-pad by adding this rotational control on the side, as well as an accelerometer. The deliverable that we're shooting for our project is a vertical slice of an RPG for this console that integrates as well as we can the crank in an intuitive way in the game for exploring an overworld and performing combat to the standard RPG mechanics that you are expecting to see from a game like this. We also want to have our visual style fully developed and have a clear and engaging story. Our goals for our process are to, by Halves, have established a strong foundation that we can use to develop, prototype, and iterate on crank interactions as fast as we can, which we think we've achieved. And again, trying to hammer home the use of that control as an intuitive and worthwhile input for the device.
So let's talk about actually developing for this device. So the Playdate, developing is pretty simple, but that's mainly because there's really no engine or anything for this. So unlike using Unity per se, all of this is just done in script. Colin and I use VS Code when we're doing the programming, which means we just write files down, a lot of importing, a lot of linking things together. Then Panic Entertainment does provide an SDK, which comes with a compiler specifically for the Playdate. So once we've created our scripts, we can compile all of that into a build, and we can upload it onto a simulator that they also provide. This simulator just runs the programs that we've created, and it allows you to get a feel for the controls of the console on your desktop if you don't have access to it. So we do iterate, when we build something, we compile it, load it onto the simulator, and then do some iterations on that, just to make sure everything's functioning correctly. But of course, with a device as unique as this, the simulator doesn't exactly capture all of the unique features of the console. So at a certain point, once we feel good about how something feels on the simulator, we then have to upload the actual game itself to the console. So we've been doing a lot of moving files around just to build something, test it on the simulator, get it on the console, see how it actually feels on the device, how it looks, how it reads, then go back to the code and start iterating on that. And so a lot of up until little past quarters has been on just building fundamental systems, seeing as we essentially start from scratch in order to actually achieve our goal of creating an experience that uses the crank, provides interactions, lets the player feel like they're doing something in a world. We need to make that world function first. And so, I mean, you don't need to understand the code here exactly. There's been a lot of details that went into this, but there's been a lot of fundamental stuff that we're building to support our ultimate goal. So generalizing the way we add activities, so it's very a generalized system. We can prototype quickly, remove or add activities as we want to test them out, so that when we have an idea, it's a very simple matter of just throwing together a mock-up and putting it into our gameplay loops for testing. Also, basic things like creating a map and creating a structure of data to quickly create props that can be interacted with by the player so that we can actually create environments to put these activities in context. Setting all of that up has been our work for about the first 4 weeks, and in the last 2 weeks, this has become pretty stabilized, and so we've been iterating on some interactions. So actually diving into the kinds of things that we've been testing in these past couple of weeks, essentially, we're going a little bit for quantity here. We're testing out various different kinds of uses of the crank to see what works best, what feels good, what makes sense in the context of our world, and what might work with a little bit of modification. Of course, when people see the crank, they think, I want to fish with this thing, so we tested fishing. You can fish in any body of water. Our foundational system can generate load-in maps that have tiles marked as water, and when a tile is marked with water, the player can now approach that body of water and sit down and cast their rod. This uses the crank in a, well, we can get into all the kinds of ways you can use the crank, but one of the main ways is just cranking really fast, just trying to get something pulled in as quickly as possible. That's essentially what this fishing game is. You reel in a fish once it's caught to try to get it to the player. Of course, there is one complication in that if the fish is pulling against you and you're pulling full force back against it, you'll lose an invisible amount of stamina, and once that depletes, the line will break. So this is a sort of quick crank mechanic that also incorporates some element of precision, knowing when to hold back so that the player has a sense of fighting against a fish using the crank. Another interaction here.
Another one of the interactions that we have currently implemented that is less directly physically analogous is digging. You can use the crank to sort of paw at the ground to, right now it just generates these sprites representing the hole that you dug and the material you moved out. But that is essentially generating some of the props that we've already made. So we're planning on using this to generate things like treasure or entrances and exits to other maps. Oh yeah. One of the other systems that we have implemented is this alchemy system. You can select from a list of ingredients, throw them into this mortar here, and then grind them up to create items. Right now it's generic and doesn't make anything specific, but we are intending to have these ingredients be collectible, and you can use this for things like making things for characters for quests or potions for yourself. There is also a fun integration of the Playdate's accelerometer that you can see in this GIF. If you put in some ingredients that you don't want, them flying out right there, that is, you can physically dump them out of the pestle or the mortar on the Playdate, which we think is pretty interesting.
And of course, those past 3 interactions were sort of crank interactions where you're just really just going at it, same direction. This is slightly different interpretation where the usage of the crank is really focused on discrete, quick movements where you're essentially chopping this log here. If you bring your crank down, the log moves sort of relative to its rotation. If you bring it down slowly and from a low height, it'll just sort of rest on top of the log. So the player needs to bring the axe head up and swing down quickly to chop into the log. And then once they do that, the axe head gets a little bit stuck. So then in order to actually pull that axe head out of the log, they need to quickly reverse the direction of the crank to pull it out. They get 3 chops and the log splits. And then this one's one of our more complicated ideas. One of the things that we do want to explore with the crank is not just creating, physical actions, fishing, digging, wood cutting, but also exploring the way that the crank can navigate menus, can sort of give a player an interface into a more abstract world. Because one of the things that classic RPG genres do a lot is turn-based combat. So we want to try to reimagine a form of turn-based combat where the crank is completely integral to the way you actually navigate that space. So this idea is one of our more complicated ones, but essentially the player is given an option. They're placed as a node on a 2-dimensional map, and then they essentially use the crank to navigate using 360 radial degree control to give them more precise control over where they're placed on the map.
So one of the things that we wanted to make sure that we included, it was a cohesive framework that kind of binds all these different interactions together and gives a general explanation as to why you're doing this. And that's what our narrative is. In order to maintain a good scope, we needed a clear and concise story with recognizable characters and thematic elements. And to do that, we settled on Aesop's Fables as it provides a backlog of characters that we can draw inspiration from and thematic elements that we can draw inspiration from as well. This led to the creation of our main protagonist, the Fox, who's an archetypical trickster character. They participate in the land's fox hunt, and they've been summoned by the king. Usually refusal just means a basic fine, but this time it means death. In the trailer before and in the examples that you've seen them performing the various crank interactions, digging, cutting wood, all that. The reason why we settled on a fox for our character is mainly just because the fox is a character that appears throughout Aesop's Fables a lot. And so we have a large backlog of stories that we can draw a reference from in terms of how to write them, their dialogue, and how to express them as a character. I'm going to be passing it on over to our art team now to talk about our project's aesthetics and how they've evolved over time.
Sure. So the main tools that we're using for art are Aseprite, Pixsquare, and Tiled. So on the right, this is Aseprite. It's a computer app. And on the left is Pixsquare, which is used on the iPad. We found that using Aseprite was better for making our overworld objects because it handles a lower resolution and animations much better. Whereas for portraits and other things that need a higher level of detail and dithering, we like to use the iPad and Pixsquare because of the touch sensitivity. As for the pipeline, we'll normally start with a general idea of the character and a sketch, and then focus on the overworld to make sure that our smaller characters are readable on our small screen. And then we can focus on a more detailed portrait to go along.
For the environments, we used house sheets to create larger environments while keeping the art style consistent. There are 2 approaches when we do this. For interiors and other structure sprites like houses, we first start with having a whole image you can see on the left, and then breaking it down into tile sheets. On the right, there's a tile sheet of the floors and walls, and we also created furnitures that are separate objects that are layered on top of the floor that programmers can add individual interactive events on them. For more organic environments, we use a different approach. Nina started with making tile sheet first, and she also created decorative items like rocks and flowers, and then making them into the environment map. And on the right is an example of an environment that she created for the forest.
And so through this artistic exploration and using 1-bit on such a small screen, we've had to make quite a few decisions. Originally, we wanted to do a lower resolution, actually halving the pixel count of the screen by drawing with 2 pixel lines instead of 1. Later, we found that it was actually harder to keep a consistent readability at that scale, so we switched to a higher resolution, and it's also just a unique aspect of the Playdate. And then another decision we made is in our map design. Right now, we use tile to create our maps, and at first we wanted to do everything on 1 layer, but we later found that if we wanted things to be layered on top of the player, and also we wanted decorations that were easily to change and be switched out, we would use a 4-layer system, starting with a base layer and then a walls layer, which our programmers can mark as all non-pass-throughable, and then we have a decoration layer and a canopy that goes over the player. This helps anyone who isn't an artist or a programmer be able to make maps following this style guide, and has helped on our forest exploration and iteration.
And so based on that, we've been able to design maps relatively quickly. We have an example up here, so you can see we start out in tiled, we export it as a separate file. If you look closely at this JSON here, you can kind of see how the map itself is laid out. And then the Playdate, it can read that through the JSON in a Lua file, and then with the tile map included, can export it as a walkable around area. And based on that, we were able to create our first large area. And main reason we wanted to have this large area was to study how large we can make individual maps without them being too large to be difficult to navigate, but also being large enough that it's fun to explore, and also providing a zone where we can test our crank interactions and see how they work within the world itself.
So with all of these foundations established, our next milestone that we're looking towards is GDC. We have 2 of our members, Sunyi and Colin, going to GDC. We want to have more of the interactions fleshed out and placed into a world that is more consistent. We want to develop the combat system more so that it can be actually play tested by other people. We want to incorporate more crank interactions, and we want to develop the sound and music as well to enforce that. And then for softs, we want to finish up the narrative progression. We want to complete more of the tile sets and more in the environmental interactions, finish the character and the music, and then refine all of that for our finals. Thank you. We're now open for questions.
What would you say is the biggest insight you have gained since this semester started in terms of the game design aspects of interfacing with the crank or developing on the system in general?
I think, at a very high level, one of the things that is interesting about developing for this console is that it has a control scheme that before now, I don't think any of us have ever felt anything similar to, especially on such a small scale, which means that when we're coming up with ideas for oh, this would be fun or this would feel satisfying to do with a crank, we've come to realize that you have an idea for, you're told, oh, this crank, it's a crank, it works like a crank, so we'll do these things for it. But then when you actually try to implement that, it's hard to actually capture what an interaction will feel like on something you've never experienced before until you actually experience it. So the process of creating a prototype that you think will work and then actually loading it up onto the console to then feel what it actually feels like, it seems kind of obvious to state, but it's a pretty necessary step of the process, because until you've done that, you really have no idea what you're developing.
I would also like to add something. I think also working in an engine that doesn't give you any sort of visual readout of the physical space, it's all just coming in from data, requires a lot more communication between me and my co-programmer, just because there's not a visual shorthand for when things are going wrong. You could sort of just get a list of errors and what lines they're on, and if it's code that he wrote, then I need to go to him, and if it's code that I wrote, he needs to come to me. Which is interesting because you get such a finer degree of control over how things work, but you lose the ease of use.
I have another question. It's all right. Let me think of what it is. So it seems like your design process was kind of like, hey, we can take fishing because that maps to a reel, or an axe, and we could map that to a reel too. But did you ever think of this process in the reverse, meaning we have this crank and we can do these types of actions with it, and these types of actions are satisfying, and then map those to different interactions?
Well, actually, yeah, I didn't want to get too much into it, but I did allude to it a little bit. One of the things that we like to think about when it comes to crank interactions is, before you think of what the actual in-game context of the action is, thinking about how you could actually use the crank. So like at a higher level, what are the broad categories of motions that something like this provides? So you do have the quick, repetitive motions, like reeling something in. You have precise balancing type motions where like the actual position of the crank matters a lot and you're trying to manage something. You have quick, discrete motions where you're not going all the way around, but you're trying to make a quick motion. Or the reverse, you're trying to, quicker form of balancing where you're moving back and forth between two states. So those kinds of categories of motion, actually woodcutting, originally the conception of woodcutting didn't come from, oh, we want to be able to chop a log, but it was thinking, what could we do that's a quick motion? Because we've been doing a lot of repetitive reeling motions.
There's also, the crank itself can deliver like information on its position in, I think, 3 different ways. It's either completely continuous, or it is kind of in ticks. So like, you can divide the whole circle into 8 parts and then measure as you go around those parts. And then you can also get just the total distance that you're moving, regardless of, or no, sorry, I already said that. The global position, regardless of the distance that you've moved for that sort of precise thing.
You can also get, this is fun, actually this is what the woodcutting one uses. You can also get you can get a degree of change that's modified by the acceleration of the crank. So basically something that takes into account speed.
You need to do faster. No, just kidding. Can you just give us a sense of the market? How many play dates are out there, sold, that kind of thing?
So as of February of last year, over 70,000 consoles were sold, and it's a relatively niche system, so that's pretty impressive. Due to the fact that it's like coded in Lua, and it's a very just kind of like quirky console itself. It's mainly targeted towards like indie game developers, especially with the retro style graphics.
Last year at GDC, it was the platform that 1% of the games that were made there were made on. So it's on the list.
And just for context, it came out about 2 years ago.
Can we use it in the NHSGA?
Yes.
Absolutely yes, and I want to talk to you about that.
All right, that's time.
Thanks.
All right. Hello, everyone. We are Team Wizard Mode, and this is our project Full Tilt. Here is our team, and our faculty advisor is Scott, and our client is ETC K-12. So ETC K-12 tasked us with the project of creating a multiplayer pinball experience that combines physical and digital components, and the primary audience being multi-generational families. The ultimate goal of this project is to create a high-fidelity prototype that encourages play among families, and this prototype will later be rebuilt and worked on over the summer and will be installed somewhere in Pittsburgh. So this is actually based on an existing pitch ETC K-12 made to Let's Play Pittsburgh, which provides grants for these types of projects to encourage play among families. And the original consisted of a storefront pop-up, human-sized pinball, and ball tracking, and projection mapping. So we took some of these ideas and also changed some aspects of the original pitch based on feedback from the Let's Play team, as well as for the particular project. So some of the aspects that we kept was that we kept projection mapping, but we're adding a little bit more digital and physical effects to it, such as holograms. And specifically, we're also adding more physical components that are more familiar to traditional pinball, like plungers and flippers. And finally, one of the biggest pieces of feedback ETC K through 12 received from Let's Play Pittsburgh was to make it more portable. So we're creating a smaller footprint for the actual experience. And here is a video demo of our experience. As you can see, I'm pulling a physical plunger over there, and me and Jasmine are actually playing the experience on Xbox adaptive controllers. The experience is projected currently on a whiteboard, but ultimately it will be a custom-built board made out of plywood that will feature 3D components to sort of emulate the bumpers and create a 2.5D effect. As you can see, there are 2 plunger lanes there, and balls can shoot out from those lanes at any point of time in the experience. And as you can see, they are different colors. So depending on the color of the ball, once it hits a bumper, it'll change the board itself. And once all 3 are hit, the board changes. And the reason for this particular design is that we can kind of create something that, a type of play that is a bit more flexible. It can potentially be a competitive experience where you have multiple players trying to compete on which theme they can switch to first, or it can be a more collaborative experience that you're trying to switch and discover all the themes the board has to offer. Additionally, the experience is further customizable by the amount of controls. You can either play it individually or you can play it with your friends or family. And that's an example of the theme switching again. And I'm going to pass it off to William to talk about the Playfield.
Thank you. So the Playfield is a central board that holds all the fun and excitement for pinball. And in the initial stage of brainstorming, we thought about different ways to enhance the experience, such as incorporating some of the fun of optical illusion like holograms, and play around with the shape of the playing field rather than square, rectangular, maybe other shape will work or not. And also adding some more mechanism to it, because, for example, multiple plungers than just one traditionally. And this is our prototype in quarters. You can see we were testing out the feasibility of the projection mapping and the quality on it. Don't blame us for using ARs on it. It's the quality checking. And also, we tested out how the plunger, 2 sets of plunger might work in this scenario. And we get a lot of valuable feedback at this stage. For instance, we realized the need to make it more kids-friendly to cater towards the target audience of the multi-generational family. And also, we want to take the full advantage of the digital form that we have to create a much more engaging and fun, interesting gameplay. And last but not least, we also want to bridge the physical and digital world together by having a physical set of flippers into the design as well. And this is some of the further iterations that we have. We thought about using DDR pad as a primary source of control because, once again, we need to think about our target audience, and we want it to be accessible for children. And this method kind of eliminates the concern about the height of traditional controls. But then we also found there's a lot of drawbacks on that, and the biggest one being that the rapid activation of like the controls you need to do in pinball gameplay, it's really exhausting on DDR pad. And that's why we reverted back ultimately to a much more universal traditional method utilizing adaptive controller and the plunger we made ourselves and to the design for a more intuitive and hands-on experience. Next, we'll have YC to talk about the contents of the playfield in depth.
Thank you. So this is the current playfield. I want to begin by emphasizing again that we're designing this playfield and we're designing our game in a way that makes our experience more enjoyable to families, not hardcore pinball players. And that's why this playfield is more reminiscent of an older pinball playfield. What we're trying to do is to keep a lot of the elements that make pinball fun to play and to watch, like flippers, bumpers, tracks, and slingshots and stuff, without being too overwhelming to the point that people with less experience with pinball doesn't know what's going on anymore. So the game works like this. Each playfield and the items within it adopts one of the 3 themes, but the layout is exactly the same as we have just shown you. And every time you pull the plunger, you get a random pinball out of 3 possible themes, and every item the pinball hits gets switched to the pinball's theme. So by designing this mechanics, we're not really setting a goal or a scoreboard for the players, but instead we're letting the players to decide what their experience should be like. It can be two players playing with one another, cooperating and trying to hit every item within the playfield with one pinball. It can be two players playing against each other, each with a different theme pinball, and see who switches more items to their theme. It can also just be a bunch of pinballs flying around, and you get whatever compositions that come up that are just cool to look at, right? So essentially, the playfield is a canvas, and we leave it up to the players to decide how they want to paint it. Next up, we have Sky going over how we come up with the different themes.
Thank you. In coming up with the themes, we wanted to create a series of boards that feel visually connected and distinct at the same time, as well as for the themes to have some relationship with the fact that we are doing a pinball-inspired experience in 2025. And so eventually we landed on the following 3 terms to describe the themes: Y2K, Frutiger Arrow, and Vaporwave. What these terms have in common is that they belong in a camp of aesthetic categories that are centered around nostalgic obsessions with the material conditions of past consumption habits. The imagery that was once central to popular culture is now recontextualized in areas such as fashion, packaging, and advertisement, and also in today's context, digital collages that are meant to reflect the aesthetics in the abstract. We believe this collection of aesthetic categories is fitting for our experience because, well, the game pinball was also most prominent in popular culture around mid to late 20th century, as well as visually pinball being very extravagant and spatially flat, which goes hand in hand with the digital collage form. And now more on the distinctions between the boards. We have some concept sketches. First up, we have Y2K, inspired by the technological development around the turn of the century. For this board, we are focused on recreating pixelated icons and interfaces, as well as emulations of smooth metallic and plastic surfaces, which often accompanied the tech products being produced in that time period. Succeeding the era of Y2K, we have Frutiger Arrow. Around the year 2004 to 2013, higher fidelity images were produced and distributed at a larger scale, resulting in the digital world being populated by this host of flat digital images that are obsessed with saturation and shine, often depicting mundane objects. And so that is the type of images we will be recreating and collaging for this board. Finally, we have Vaporwave, a popular music genre around the 2010s. Vaporwave is often accompanied by a visual component that heavily references past popular culture, thus overlapping a bit with the 2 previous aesthetic categories. However, Vaporwave also takes iconic imagery from throughout history and around the world, putting them all into the digital setting, thus resulting in this neon-colored, spatially ambiguous, anachronistic collage, which is what we are going to be emulating. Next up, Jasmine will talk about our playtest findings.
Sure, playtesting is important, especially when we're using these unique controllers. In the playtest sessions, we set up the large buttons from the Xbox adaptive controller to control the flippers, and we set up the physical plunger with the Arduino kit and ultrasonic sensor to launch the pinballs. So in the playtest sessions, we mainly ask 2 playtest questions. The first one, how do you feel about controllers? And the second one, how do you feel about pinballs in the digital world? Fortunately, we got some positive feedbacks. We gathered some impressive quotes from the players that I do want to read out loud to share with you. The first thing was the player felt the multiple pinballs in the digital world really made for a fun experience, saying that it's different from what they've seen in the traditional pinball machine, and it is really fun. The next thing is adaptive controllers. They were really well received in the playtest sessions. One player even mentioned smashing the large buttons really reminds them of the simple happiness from childhood. These comments made us confidently believe that we are on the right track because our essential goal is to build a fun experience for kids, for adults, and for the elders. However, there are some negative feedbacks, but it's very precious because it tells us what we can improve in certain aspects. The thing that stands most is the plunger, because for now we're using the cardboard and tape to build our plunger, and so one of our teammates needs to hold and press the plunger the whole time during the session to keep it from moving around. So what we're going to improve is that we're going to replace the cardboard with plywood to improve our plunger build and to reinforce the correct feeling.
Additionally, now in the digital pinball world, the player felt the physics is kind of slow. So luckily, we're using Unity to develop the game experience. So we can always have more playtests and adjust the best gravity value to play with. Moreover, the player wish that they could have more parts in the digital pinball world to play with, such as the smashable items or even like more interesting things that could only be seen in the digital pinball world. So last but not least, let's have Cynthia talking about our next steps.
Thank you, Jasmine. Let's talk about our next step. At this point, we have successfully implemented part of the physical components, including the plungers, projection, and buttons. And from the result of our playtest, the players have given very positive feedback to our design, showing they are engaging, so we are on the right track. However, there are still some challenges that require our further development. First, we need to build the physical boards ourselves, which is already in progress. We have a wooden board and put it in the wood shop. And once we finalize the size of it, we'll cut it accordingly. We also want to reinforce our control system to get a more immersive and a better experience, such as like adding the physical flippers to the board and also improve the build of our plungers. In addition, we will need to figure out our soundscape. So in the following weeks, we will focus on creating dynamic playfields with different themes, implementing the sound to the gameplay to complete the experience, adding the physical components to the board and ensuring they work well together, and finally test the game with multiplayer and families to see how they react with each other. And by the end of the semester, we are confident in delivering a well-polished pinball experience. So this is the end of our presentation. Thank you for listening.
Are you guys planning on the different themes having different boards, like for the actual game, or is it the same board that is going to be rethemed?
So the theme will be different for different playfields, but the layout is the same, remains the same across the themes.
Right.
Can you speak a bit to the multiplayer aspect and how that play is designed toward different generations? Like what if you have an elder and a kid playing together? How are they played differently or played together?
So how our experience currently is designed is that we have 2 sets of plungers and then 2 sets of adaptive controllers. So that way, you can put the adaptive controllers on top of each other to play individually, or if you have a family playing, maybe the kid wants to like pull the plunger and just release a bunch of balls into the experience, and the adults are like hitting the plungers, or vice versa. Essentially, the experience is designed so that way, you know, as traditional pinball is more competitive, this is sort of designed where families can sort of design their own play experience of like, oh, do they want to play competitively? Or if it's like younger children, do they want to play more collaboratively or just have fun with just shooting a bunch of balls into the experience? I think one thing that we did notice is that with most pinball experience, multi-ball, which is like when a bunch of balls get released into the space, is kind of something that only is activated when you like win something within, or like you activate something, get a high score, whatnot. So in this experience, you have that option from the get-go, and that way it allows people to be able to experience the fantasy of multiplayer pinball, or like multi-ball pinball, without having to be experts at it.
Yeah, and just to add on to that, having multi-ball as a default setup also eliminates the scenario where, you know, someone loses a ball and like players start blaming each other and that kind of stuff.
I'm glad you guys are addressing the thunk,
I agree that's a critical part. Do you think that once you do hit that there's going to be a greater expectation for the ball moving higher? Because the thunk is part of the launch. So the more meter the launch is, I expect it to go higher. I noticed you guys had a short board. Do you plan to increase the size of your board? But I know you're also talking about complexity. So are those two things working against each other, or is that something you anticipate?
So for the thunk, actually, so with the sensor and how it's set up right now, it actually does go higher if you pull it farther. In terms of the board size, we are a bit limited because of the kind of our design is primarily in this 8x4 space. So we are a bit limited to the size, but I think there's definitely ways that we can come up with cool effects. Like, for example, one of the ideas is like, depending on how far you pull the plunger, a different VFX will happen, which, if William, if you have any, yeah.
Related to that, I was kind of wondering, in terms of like pinball games from the past that you've taken inspiration from, I know, I'm not an expert on pinball, but I know there was like a Kirby pinball game where, I mean, it was on the Game Boy, I think, so the screen was very small, but the way they achieved height was by essentially using the digital world to their advantage by making it so that the pinball could leave one screen and enter a screen that is at a higher height. Have you considered like that space at all of like, because you're using, it looked like a projection on the world, you're not limited by physical space, like maybe creating a larger space that the balls can move through?
I think definitely in one case. And also, we also wanted to kind of bridge, we want to have certain physical elements on the board itself. So, for example, the physical flipper, that might have some limitation of like actually scrolling or expand upon the playfield digitally. But I think that's definitely a good direction to look at for sure, because that'll create a lot more interesting scenarios.
That's time. Thank you.
Okay, last but not least, we are Team Encore. My name is Sarah, and this is my team, Jasmine, Anna, Devika, Faye, and Jim. We have our lovely faculty advisor, Cheryl, and our client/collaborators, TJ, Lillian, and Madeline. So for our project, we are creating an interactive exhibit to go in the Purnell lobby, which will immerse the guests into the world of Titanic and prepare them for the musical. To do this, we are using lighting, audio, and interactive set pieces. So now, what is Titanic the musical? It is very different from the movie. It focuses more on the real-life passengers of the Titanic and looks at their hopes, dreams, and aspirations, as well as focusing on themes of fate and class disparity. So now for our target audiences, we have this kind of divide between the young adults and older adults, young adults being undergraduate students who are at the School of Drama, specifically more of the freshmen, and then older adults being more frequent theater goers, potentially CMU School of Drama 4-play pass holders. Then we also have this divide between people who have a good understanding of the Titanic and a limited understanding where they might think they're going into more of a musical version of the movie. So here we have our project goals. We're creating a lobby installation, preparing the audience, and intending to complement and enhance the show. And then we have some more emotional goals as well, where we're hoping to engage with the stories, emotions, and historical realities of these characters and the real-life people that were on the Titanic, as well as create a connection with the musical characters, highlight themes of inequality and fate, and have passenger stories remembered. So here we have some of our original concept art. On the left was a concept drawing of one individual luggage station, and these two images on the right would be the whole lobby of what it would look like. These are AI-generated images. The middle one would be the pre-show lighting, and the one on the right is more of the intermission lighting, which will go in a little bit more details shortly. Now I'll hand it over to Anna and Devika to talk about the user journey.
Thank you. So our experience consists of 3 different parts: the start, intermission, and end of the musical, where the guests will experience the emotional shift. At the start, the atmosphere is more cheerful and hopeful, with them boarding on the Titanic. During intermission, which is right after the Titanic hits the iceberg, they can feel more of the chaos with cooler colors evoking the colder ocean. In the end, after the show, the lobby will offer a quiet atmosphere, allowing the guests to fully immerse themselves in the silence and reflect on the victims. The space will be decorated to resemble a starry night sky, a visual inspired by the survivors' accounts of what they saw as they returned to shore.
As for our user personas and our audience, these would be the people who we expect would interact with the experience, and we'll create distinct user journeys for all our user personas and distinct user journeys for every possible combination of the 3 phases that they could visit. So we want to ensure that her experience feels complete, even if someone misses one or more parts of the experience. And creating user journeys like this helped us make some important decisions, like whether we should include characters from the musical only, or if we should have our focus being people who never got a chance to have a spotlight like this. And mapping user journeys made us realize that using different characters would be distracting and take away from the experience of both the musical and the lobby experience. This is a basic outline of our user journey during all 3 phases. So as the guest walks in and notices the luggage trunks and the stations, once they walk past a station, they're going to hear an audio recording of a character's voice, and a string of lights is going to turn on, tracing a path along the props inside the luggage, causing them to look inside and interact with the items inside and explore them. And as they explore further, they're going to notice other stations and see a very stark difference in the class disparities and the socioeconomic status of the characters around them. So during the intermission, we expect that characters are going to come outside to look for we expect the guests to come outside to look for characters who they are interested in from what they've seen in the musical. And as for the ending, we don't really expect a lot of interaction with the luggage, as much as taking in the environment changes with the lighting and the sound.
To add an interactive element to the experience, we initially introduced the idea of writing messages on postcards. During quarters, however, we received feedback that it lacked engagement, and also that it wasn't as motivating as writing in something else. In response, we conducted research on the Titanic's Marconi room, which was used for communication through Morse code. We adapted this old-fashioned telegram communication into a more dynamic experience where the guests could become one of the passengers that boards on Titanic and leave their final messages of love, regret, or farewell into a microphone, which will then be displayed on screen with engaging visualizations. Also, they have the opportunity to witness other people's messages on screen, which will create a shared moment of connection on this historical event. Now, Devika will talk more about the narrative.
Thank you. So as for our narrative, we're picking 2 characters from each class and a crew member and a musician. So for today's Halves presentation, we're focusing on third-class passenger Kate McGowan, and we'll delve into her life through the luggage she would have packed while boarding the ship. So we've carefully chosen 6 props for today that would highlight her class, her socioeconomic status, her Irish Catholic background, and her dreams and hopes for a better life in America. And among these props, you'd also notice letters, which is something that we're planning to include in all our character stations. Letters, diaries, journals, pocketbooks, and we'd be conducting a lot of research into how each character would have written and spoken and trying to mimic those in the fictional accounts that we would be making for them. And now Jasmine's going to talk about how we're going to bring these alive through our hardware.
Thank you, Devika. So each of our luggage stations are equipped with a host of electronics that will make each of these interactions possible. First, it starts with a time-of-flight proximity sensor. This sensor allows the Arduino Uno microcontroller to know when a guest is within a certain range of the luggage. So once the guest enters this specific range, the Arduino Uno drives an output through a DF player. This drives the character audio through a speaker, which is what allows the guests to hear the audio. The Uno also drives a strip of NeoPixel LEDs. This is what illuminates the lighted path along the props within the luggage. Using these elements that we were able to get in last week, we created Kate McGowan's luggage right here. For those of us in the front, if you'd like to lean in, you can see it. For those of us in the back, we have a video. There we go. As we approach the letter, in the final audio, we will also have the letter narrated as well. Thank you to Libby Egan for giving us her voice for our demo. Now that we've seen one of these luggage stations, this is what the layout of the Purnell lobby will look like. We'll have 8 of these stations, 1 per character, spread out throughout the lobby. Specifically, station 1 is more to the left in a more spacious area because this will be dedicated to our musician character. We wanted more space for this character, so we had the space to showcase his instruments within his luggage. We will also have our telegram booth near the back by the box office. This creates a more private and intimate setting to do this interaction within. And we also have some draped fabrics along the pillars that align the entrance to Purnell. This will add some ambiance to our space. Now I'll pass it off to Jim, who'll talk more about the telegram technology.
Thank you, Jasmine. So for the Marconi room, we developed an interactive telegram system based on Unity and Hugging Face API. So our audience who experience this part can speak something, and the Unity will get access to the microphone and save the voice clip as a WAV file. Then the Hugging Face API will turn it into a text file, and based on that, our designer can turn it into some text VFX. And here is the recorder demo based on Unity. So the audience can hit the record button, speak something, and then hit the stop button, and the voice clip will be formed. Then you can see the text displayed on the screen, and there will also be a text file saved. And based on this file, our designer made this effect based on the P5.js. It's the wave of the string, and it's a symbol of the message still existing even after the messenger has gone on Titanic. And then Anna will talk about the playtest part.
Thank you. So our team conducted several playtests to confirm the hardware and also enhance the usability for the prototype. We tested the directional speakers used by the last year's curtain call team, but decided not to go with them because of the insufficient volume and depth of the sounds. For the telegram, we tested a brief version for our prototype with 5 playtesters on playtesting night. They spoke that message into a mic, which was displayed on screen with other messages. From this test, we learned the importance of a private background setting so that the guests could fully engage their emotions with the emotions that we want them to engage. We also received valuable feedback on how to display the messages more effectively, with suggestions to incorporate visuals that reflect the Titanic experience. Based on this, we've adapted our current design, which will be further refined in the future. Now, Faye will talk more about our future plans.
So looking forward, playtesting will be a crucial part of our process. We are going to see Ghosts in Trotsky Theater this week. The idea is to see how many people will engage with the space during key moments, and this will help us optimize our experience for the similar conditions. And now that since we have one completed suitcase, we'll use that to test whether people want to pick up the item inside and how they engage with the narrative to refine our storytelling element. And we'll also be continue developing and testing the telegram iterations, including finalizing hardware design, making sure it aligns well with our overall aesthetic. And let's talk about some challenges we face. So first, we have very tight deadline. The installation date is 2 weeks before final. And to tackle that, we create detailed schedule and scope our work carefully to make sure we stay on track. And next, lighting has been a challenge for us since it's a new skills for all of us in the team. We've been working closely with Drama and explore what equipment they have available for us. And we're also planning on meeting with a lighting designer for advice. Finally, there's a potential issue of guests might missing a face if they, if for instance, they don't go out during intermission. So we are playtesting that to make sure our narrative and emotional journey remain impactful no matter how much of it the guests interact with. So here's our schedule for the following weeks. We are planning to get more luggage stations done, and the goal is to get all of them done by week 11. Our installation will be on April 12th. Our team will be there in the lobby on site from the opening night on 15th to the closing night on 23rd. And to wrap up, the goal of our project is to complement and enhance the emotional phases of the show by creating an interactive luggages and a telegram booth in the Purnell lobby. We are creating an immersive experience to prepare audience for Titanic the musical. Thank you. We are now open for questions.
So you have 8 stations, right? 8 luggage stations. Every station has an interactive element to it where you're hearing a voice, person talking. And are those voices, are those stories taken from actual survivors' personal accounts, or they're made up?
So each of the characters are real-life passengers. So these are the people that you'll see in the musical, and we've done deep research onto each of their lives to find out what objects they would have taking with them on the journey, and also looking at any different letters they've written that still exist that we can look at, and then drafting our own to kind of be what we would, picturing their voice in these letters.
Okay, thank you.
Are you going to use the actors for your voiceovers?
Yes, we're working with Drama to make sure that the actors who are in the musical can help us, and if not, then some other actors who can help us with that.
I think the team has made a lot of really good decisions, so I'm just going to preface my question with that. I don't understand the LED light and what story it tells or why you need it. Can you tell me more about it?
So the LED light is meant to be a way for the guests to have a place to know where to put their eye as we as they hear the audio, because sometimes when you're just listening to something kind of just talking, it may be easy to get disengaged and just like let the words kind of just go past you and not really listen. So we thought the LEDs would be a way to be like, okay, I'm hearing this, I'm seeing this, I know I'm supposed to be looking, because as the audio talks, it talks specifically about the prop that it is passing by. So we create the whole like audio and visual experience.
Have you thought about projection mapping it instead, just so it's a little more integrated?
We haven't thought about projection mapping. We do think the lighting is the simplest answer, because it allows us to still have the, so the idea would be like projection mapping on top of the physical props, is what you're saying?
Correct, yeah.
It's the issue with that would be fitting a projector within the space would be harder than just having the strip of lights just within the luggage. But we could think about that and how that could potentially work in the space.
So one thing that you mentioned regarding how the luggage works is that it's based on proximity to it. I'm curious in terms of like how the audio is going to work, because if it's a busy lobby, and you were even bringing that up with how you need to change what speakers you were using. Are you planning to have it so that way when more people are around the luggage, the audio is louder, and when fewer people, it might dim, and maybe as like somebody's walking away, it'll like constantly check that, and maybe the audio will die off? Or just how do you plan to like use proximity to your advantage within a space that can also just get very like noisy very easily?
So the idea is that the only person that can hear it is the person that is like up like in front of it. We don't want it to like blast to a huge group of people, because we want to prevent sound bleed between all the different stations. So currently the speaker we're utilizing is a 3-watt 8-ohm speaker, which is small but can get pretty loud. You can hear it. You could hear like music playing from it amongst a conversation around you. But we did want it to feel the experience to feel a little more intimate, rather than we're doing this one luggage for a huge crowd. So we did want to just be a little bit more individualized.
Gotcha. Thank you.
I'll just offer a bit of encouragement to keep following that point. When you go this week, look at the crowd. I'm guessing they're not going to be 40s and 50s, so they're going to be 60s and 70s ages. Their hearing will be so-so at times, and the space is going to get loud. So even speaking, I was surprised that you're going to speak to send the telegram, because I just have a feeling that the audioscape is different than what you expect.
We've been to the lobby a couple times to see how we could fit it in, and we think the 8 station will work well, and that way we can have 2 from each class, and then the musicians and the crew, but then also being willing to cut down to 6 if we need to, given space and scope.
And that's time. Great. Thursday. My wife, my daughter, and I will be there Thursday. I'm not sure when you're But just look, because the space freakish loud, especially like 20 minutes before you start.
Mount your lights on the top of the suitcase and have them spotlighted, and have them turn on one by one as the talk. Please, Jasmine, please. Please, I'm begging you, hands and knees, Jasmine, hands and knees.
We're already sourcing our use cases, right?